This is an ant. You've seen thousands of them, ignored most of them. Maybe paused once to watch a column of them move across a sidewalk with that eerie, lockstep precision that makes them look less like individuals and more like a single thing pretending to be many. They are everywhere. They are ancient, and for the most part, completely beneath our notice. But this one is different. This ant has been walking for 4 hours in a direction it did not choose. It left its colony and has been moving through the undergrowth with quiet, unhurried purpose that looks, from the outside, completely normal. Nothing suggests distress. Nothing suggests confusion. It looks like an ant going somewhere. The problem is that whatever is making that decision is not the ant. Free will is a beautiful concept. Ask the ant how it's working out. Everything you learned about infection assumes a recognizable script. Something gets into a body. The body fights back. One of them wins. Ophiocordyceps is not running that script. This fungus does not want to disrupt its host. It wants to operate it. It hijacks the ant's motor control, navigates it to a precise location within a 2 to 3 centimeter height range, refined across millions of generations, and kills it in exactly the right position to launch the next wave of infection. If we mapped the chemical toolkit Ophiocordyceps uses to override an ant's muscle system, the complexity would rival a targeted pharmaceutical intervention engineered in a modern laboratory. Except no laboratory designed this. A fungus worked it out alone, through nothing but pressure and repetition. We are not living in a world where only animals have strategies. We are living in a world where fungi have been running behavioral modification programs since before brains were a widespread feature of life on this planet. And it gets weirder. Meet Ophiocordyceps Unilateralis, a fungus so narrowly specialized that individual strains evolved to target single species of ant. Not ants broadly, one species, one host, one outcome. The fossil record places this exact relationship at least 48 million years ago. The distinctive lockjaw grip that infected ants leave on leaf veins before they die has been found preserved in amber from the Eocene epoch. The fungus was executing this maneuver while the continents were still moving into positions we recognize today. It has not changed the strategy since. It did not need to. Here is how it works. A healthy ant contacts fungal spores on the forest floor. The spores penetrate the cuticle and begin growing inside the body cavity. For days, nothing looks wrong. The ant forages, communicates, carries out its social role, without any visible sign of compromise. The fungus threads itself through the body the entire time, consuming non-essential tissue with careful restraint, keeping the host functional because a dead ant at this stage is a failed operation. Then the behavior shifts. The ant loses its orientation to the colony and starts climbing. And here's where the research becomes genuinely strange. The fungus is not doing this by infecting the brain. Brain tissue in infected ants has been examined and found largely intact. The fungus is not rewriting thought. It is bypassing it entirely, interfacing directly with the muscles. Fungal cells surround individual muscle fibers throughout the body, producing compounds that cause those muscles to contract independently of whatever the nervous system is instructing. The ant's brain may still be issuing signals. The body has simply stopped taking its calls. The ant climbs to 25 centimeters above the forest floor, moves to the northwest side of the stem, where humidity sits within the fungus's preferred parameters, bites down on a leaf vein with a force that locks the jaw permanently, and dies, facing downward, so that the fruiting body emerging through its head releases spores directly onto the path below, directly onto the path where other ants will walk tomorrow. The math says a fungus should not be capable of this level of behavioral precision, but it is, and it has been for longer than our entire genus has existed. The 25-centimeter height is not an approximation. Researchers measuring infected ant positions across multiple forest sites found the consistency significant enough to indicate active regulation. How an organism with no nervous system assesses elevation and humidity with that accuracy remains genuinely unresolved. If you picked up an infected ant during the manipulation phase, it would feel completely normal, purposeful, directed. Nothing would register as wrong, which is more than can be said for most of us on a Wednesday afternoon. At least the ant has a destination. Someone made absolutely sure of that. But that is not what keeps parasitologists awake. This is. The colony knows something is wrong before behavioral changes appear. Healthy ants carry infected nestmates away from the colony during early infection, responding to chemical signals that indicate compromise before any visible symptom emerges. And Ophiocordyceps, across 48 million years of coevolution, evolved to run its program fast enough to get the ant out before that detection system catches it. The parasite and the colony's social immunity have been locked in an arms race longer than mammals have dominated this planet. Neither side has won, both keep evolving. The current leading hypothesis centers on the neuromuscular junction, the interface between nerve signal and muscle fiber. Ophiocordyceps produces compounds that insert themselves into that interface, intercepting communication between the ant's nervous system and its muscles. The brain issues a command. The fungus is already there. The muscle receives different instructions. Three-dimensional imaging of infected tissue revealed that fungal cells form a body-wide network surrounding individual muscle fibers from head to abdomen, a distributed control architecture with no single point of failure. No command center to disrupt. Control everywhere simultaneously. Engineers designing fault-tolerant systems would recognize it immediately. A fungus built it 48 million years ago without a whiteboard or any awareness it was solving anything at all. If a fungus can override behavior without touching the brain, directing movement, suppressing instinct, scripting an ending without the host's nervous system consenting, then the relationship between a body and the thing controlling it is more negotiable than we assume. The ant's brain may have been fully present for all of it, generating signals, issuing instructions, simply not being heard. Humans have debated free will for thousands of years. Ophiocordyceps does not debate it. It demonstrates, in the body of an ant on a rainforest floor every single day, that behavior can be authored by something other than the mind of the creature performing it. The ant walked to its death with direction and resolve. Something else had written the route. The walking was just the final delivery. That has been true in that rainforest for 48 million years longer than humans have been around to find it unsettling. But if Ophiocordyceps can commandeer a body from the inside, routing instructions through muscle and chemistry, bypassing the brain entirely, we have to ask what happens when the organism doing the rewriting is not a fungus in a rainforest, but something microscopic, airborne, and already present in the bodies of several billion people. Because researchers have been looking at exactly that question, and the early findings are not reassuring. The answer is not where you would think to look. It is actually hidden in the place we have been calling instinct all along.